This revision pack is to help you with chemistry, specifically Unit 1 about atomic structure and Unit 2 about bonding. If you haven't tried it before looking at the video, then you need to try it first, because that's where learning comes from. You're trying it yourself, retrieving the knowledge, giving it your best go, and then using this to check or go over things you're not sure on. So, if you haven't done this question, can you pause it now, have a go, and then listen and find out the answers? Well, first thing you need to do is read the question. So the diagram represents a carbon atom, and I've got a key of electrons, neutrons, and protons. So what I could do, I could just start off by counting some protons. 1, 2, 3, 4, 5, 6. So I've got 6 protons. I've counted the neutrons. I've also got 6 neutrons, and I've got 6 electrons. And I'll also notice that in the first shell, I've got 2 electrons, and in the outside shell, I've got 4 electrons. So that's the electron configuration. Now, the question says use words from the box, so use one of these to answer the questions. What is the name of the central part of the atom? Well, this whole central part, which includes these two, is called the nucleus. So let's put that in. If you're given the spelling, you need to make sure you spell it correctly. Next up, what is the name of the particle with no charge? Well, I've got electrons, neutrons, and protons. So which of those has no charge? Well, the answer is the neutron. Because electrons have a -1 charge, protons have a +1 charge, neutrons have no charge. Makes the next question really easy. Name of the particle with a negative charge is the electron. Now all those questions are all AO1 questions, so this is where your knowledge learning has to come in to just know the answers to these. The next question says use the diagram, so make sure you're looking at the diagram above to help you answer. Draw a ring around the atomic or the proton number of this carbon atom. So carbon, well, the number of protons it's got is 6. So therefore, here's your answer. Drawing around the mass number. Now, mass number is the sum of protons and neutrons. So I've counted up already. I've got 6 protons and I've got 6 neutrons. So therefore, the sum, the total, is 12. So my mass number is 12. That makes this as the carbon atom. Again, try this page if you haven't already. A different carbon atom has 6 protons and 8 neutrons. Drawing around the whole symbol. So, where we have a symbol, the bottom number is the atomic number. This is the number of protons. The top number is the mass number. And this is the number of protons add neutrons. So from the question, I've got 6 protons, so it can't be this. So I'll put 6 in there. And I've got 8 neutrons. So for the mass number, 6 add 8 equals 14. So therefore, this is my answer. The next diagram shows bonding in a methane molecule. Okay, so methane is this here, and it's got a carbon with 6 electrons. Now the first thing you might know about carbon with electrons is you put 2 in the first ring and 4 on the outside ring. So you can see it's only included the outside shell. Hydrogen has 1 electron, therefore it's only got the 1. Because carbon's got 4 valence electrons, so 4 electrons in the outer shell, it's going to try and make 4 bonds. Hence the fact it's 1, 2, 3, 4. To draw a ring around the formula of methane, well, I've only got 1 carbon, so that can't be right. And I've got 4 hydrogens, so this is your answer. Draw a ring around the word that describes methane. Well, an element is only one type of atom. That's not correct because I've got carbon and hydrogen. A mixture is 2 different types. of atom, two different types which are not bonded? Well, clearly, the question shows bonding, and there's a bond between the carbon and the hydrogen. So therefore, it's not mixture either. So therefore, your answer is compound, which has different atoms chemically bonded, because I've got carbon and hydrogen bonded together. Last one, a ring around the type of bonding. Well, ionic means it makes ions. An ion is a positive and a negative charge. I don't see any positive and negative charges. And metallic is where you've got metals bonding, and hydrogen and carbon are non-metals. So it's not metallic, it's not ionic. The answer is covalent. Again, let's unpack that. Co, meaning together. Valent, meaning the outside or outer shell electrons. So covalent, they share a pair of electrons. And this is what has happened. The carbon shared one electron, the hydrogen shared one back. So overall, they share a pair of electrons. Next, electronic structure. Well, I've got 13 in total. Max in the first ring can be 2. Max in the second ring can be 8. So if I put 2 into the first ring and 8 onto the next ring, that makes 10. Overall, I want 13. So I've got 3 more. So it's 2, 8, 3. Name 2 subatomic particles. So subatomic means smaller than atom. So the 3 things that make the atom are the proton, neutron, and electron. So which 2 are in the nucleus? Well, the answer is the protons are in the nucleus and neutrons are in the nucleus. Next question, why is there no overall charge? Well, let's think of these 3 particles. Protons are +1, neutrons have no charge, and electrons have -1. So, in a normal aluminium atom, the number of protons equals the number of electrons. Therefore, the number of positives equals the number of negatives. Neutrons don't matter because neutrons have no charge, so we don't really include them in this kind of question. The next question is asking me to balance this chemical equation. So what you do is you count up the number of each type of atom on each side. So I've got 1 aluminium there, I've got 2 iron, and I've got 3 oxygen. I have 2 aluminium, I have 1 iron, and I've got 3 oxygen. So I've got the same number of oxygens, so I'm happy with my oxygens, don't need to do anything there. But I've only got 1 aluminium here and 2 here. So I need a big 2 here, so I've got the same amount of aluminiums on each side. And I need a big 2 here to get the same amount of iron on each side. So why does aluminium react with iron oxide? Well, this is a displacement reaction because aluminium is more reactive, so it's higher on the reactivity series than iron. Next up, we've got a word equation for magnesium burning. So magnesium add oxygen makes magnesium oxide. Draw one line from each substance. So magnesium. Well, magnesium is a metal. If you look at the periodic table, here's your staircase. So all of these are metals. Here's magnesium in group 2. And these are non-metals. So magnesium oxide, well, that's made of 2 different elements. So this is a compound, and oxygen is a non-metal because I can find oxygen here in group 6. Again, we've done a few similar questions to this. So neutrons have no charge, and electrons have -1. Drawing around the correct answer to complete the sentences. In magnesium atoms, the protons and neutrons are in the keyword is nucleus. The number of protons in a magnesium atom, so the number of protons is called the atomic number. And the sum of protons and neutrons is called the mass number. Now, this is the hardest question in this revision pack. So sodium reacts with chlorine to form the compound sodium chloride. Describe in terms of the electron arrangement the type of bonding in firstly a molecule of chlorine. So we'll start with this one. So a molecule of chlorine is Cl2. So it's Cl bonded to Cl. The first thing I'm going to do is I'm going to find chlorine on the periodic table. It's in group 7. And it's got 17 electrons, and I'm going to draw it. So inside ring, second ring's full of 8. It's in group 7, so it's got 7 on the outer shell. 1, 2, 3, 4, 5, 6, 7. So the first thing I can do is I can really notice that it's got 7 on the outside shell, so it wants 1 more to be stable. So can it gain an electron? No, it can't, because there's nothing to gain it from. 1 chlorine, it doesn't want to gain 1 because it doesn't want to give just 1 away. So it can't bond ionically. Also, if you're looking at chlorine, chlorine's found in group 7 here. So this is a non-metal. Okay? So non-metal to non-metal makes a covalent bond. So let's start it off. It has covalent bonding. Why is it covalent bonding? Because each chlorine atom wants to share a pair of electrons to become stable. So that's in words what's going to happen. The best way to represent this is using a diagram. We only need to do the outside ring. So chlorine with its outside ring, dot and cross diagram, bonded to another chlorine, share that pair of electrons, and this is how the bonding looks in chlorine. Let's check if I've got 3 marks. I've said it's covalent bonding. I've said they want to share a pair of electrons, and I've given a diagram. I've explained that chlorine's in group 7, therefore it's got 7 electrons on the outer shell. Happy with that for 3 marks. Next up, sodium chloride. Again, I would try and draw them. So sodium is group 1 with 11. So 2 in the first ring, 8 in the second ring, and 1 on the outside. And chlorine is, as we've said, group 7, so 2, 8, 7. So sodium would want to lose 1 electron, chlorine wants to gain 1 electron. So the first thing that happens is electron transfer. Electron transfer. And this results in sodium being left Na positive and chlorine Cl negative. These opposite charges attract together and they form that ionic bond. If we're looking at the periodic table, sodium is here in group 1, so it's a metal. Chlorine is here in group 7, so it's a non-metal. A metal bonding to a non-metal is ionic. So, in terms of electron arrangement, describe the type of bonding in sodium chloride. So it's ionic. The reason, sodium has the electron configuration 281, so wants to lose one electron. Chlorine has the electron configuration 287, so wants to gain one electron. Therefore, you have electron transfer, leaving Na as Na positive and Cl as Cl negative, and these opposite charges attract.